Great.
All right, thanks, Panos. Thanks, everyone.
Hello, welcome. It's a big crew. Welcome to the 46th version, right, of London DevOps. I want to thank all the organizers for sharing the stage with us tonight here. And welcome to Funding Circle. So, I'm Panos. I'm a principal engineer for the platform team here at Funding Circle. Been with the company for about 1.5 years now. And if you want to follow me, this is my Twitter, this is my GitHub, my webpage. Or, of course, you can chat with me after the talk. Today, we're going to talk about a story around scaling, let's say. We're going to go through an introduction about Funding Circle, a scaling timeline, the current state, vision, and questions. I'll try to keep it short because I have pizza waiting for you. So if you're very, involved in the whole talk, perhaps we can save a couple of minutes and go faster to the pizza. So about Funding Circle. Funding Circle is a loan platform. We focus mainly on small business. The company was founded in 2010 and since then has expanded in the US, Germany, and Netherlands. It has originated more than 7.5 billion in loans. Originate means that we actually funded loans of 7.5 billion. And we helped more than 70,000 businesses, including, of course, a lot of local businesses here in the UK. We have an engineering team of 280 people, and our platform team is a size of 40 right now. About scalability now. So you've heard about this term so many times, and the actual answer to a simple question, what is scalability, and based on Cambridge Dictionary, is the ability of a business or system to grow larger. In our context, of course, we're always talking about resource scalability. And as we know, there are two main dimensions. One is the horizontal, and the other one is the vertical, with horizontal meaning that we essentially add more nodes/replicas. And the vertical is adding resources to an existing node/replica. However, I have $1 million question for you, and I'll explain why. This is a question we get all the time, like, can this system or application or solution scale? And Tony Stark here is pretty excited with this question. So the $1 million question is because if only we had a penny every time we're getting this question asked, we would have probably millions by now. And I want actually your input on that. How would you answer to this question? So let's say someone comes to you from your product team, let's say, and say, hey, we want to do this. And what do you think? Can this scale? Anyone? No is a very valid question. Answer. Anyone else?
What's the design of it? What's the deadline?
Another one, the deadline. Very good. So, it seems we're all on the same page here because what I would say is that it depends. Every year now we have new variables in all the projects we're running. And what I mean variables is either external dependencies or new things coming in from the business. So, if we start from the beginning, let's say when everything was nice and simple, that means on-prem. I mean, that was a joke, but yeah. So we could be like, we could have new resources based on utilization. Every time we had essentially to check for memory, CPU, requests later on. And we had to do this great process of capacity planning. How many of you have actually been through this process of capacity planning? Okay. So, of course, as you all know, this was very heavy in operations because you had to do it like in a monthly or a quarterly basis. And the response to all those incidents was kind of slow. And what I mean incidents is even like increasing capacity because you had actually to buy the servers. So Amazon wasn't that big even back then for servers and stuff, right? So you had to actually go for procurement, do all those great things that we all know, and end up with the servers. So then, we started talking about cloud, which essentially in the first version, so we're talking about early days of 2006, for example, The actual problem that it solved was that we didn't need anymore to talk about capacity because we could create as many instances, let's say, we wanted. And that was actually the first time that we talked about, well, we didn't talk about it back then, but we actually started working on some DevOps concepts. And that was mainly because most of the applications back then were not ready actually to be run in systems that were pretty far, let's say, from our control. We still had kind of slow response, but this response to an incident, by the way, it's not right, actually request response time. But we still had needs for provisioning and for orchestration, because back then, again, we just had like the VPS essence, let's say, of a server. And then auto-scaling came into the play. 2010, everyone is very excited, and the guys from South Iraq were also excited. And essentially what it allowed us to do was to just, with a simple click, increase the capacity, let's say, that we had in our backend service in AWS. However, in the same time, we had a few events coming in. Like, first of all, the rise of PubSub. Back then, of course, most of people were using RabbitMQ or something equivalent with Java, because those were the first versions, let's say, around message brokers. And streaming platforms, because Apache Kafka came, it was open sourced in 2011, although it wasn't mainstream back then, but LinkedIn made it essentially open source in 2011. Docker containers appeared end of 2013. Infrastructure as code, first version of Terraform 2014, and the same for CloudFormation. All those tools were not popular, of course, right away, but they became popular a few years or a few months later. We also had like adoption of microservice architecture. All, let's say, teams started essentially using microservices and getting rid of monoliths. And because of all those reasons, CI/CD was something that everybody needed. Imagine having like thousands or even hundreds of thousands of microservices. How can you deliver them? Which gets us to the point of a workload orchestration. Workload orchestration is not a concept that was actually introduced because of the containers, but sooner than later it was kind of combined or connected, let's say, to it. The main reasons were that Docker became mainstream, so everybody started working with Docker because it was really easy for developers to use. There were other solutions back then as well, like the jails from FreeBSD and even the actual Linux containers, but developers were not very comfortable with them because they required also skills from an infrastructure point of view. And of course, orchestration was required because we ended up with hundreds of containers. At the same time, some open source projects, for example, Mesos, were becoming more and more popular back then because Mesos started as a simple orchestrator before Docker, before everything. It just added the support for Docker and Rocket later on in 2014. But the essence of workload orchestration was there already. Then, of course, Docker Compose came into play, Kubernetes first version after Borg, and Docker Swarm. And that leads us to today, that we have Kubernetes is the mainstream choice, is the new black, as they say. More and more teams use distributed architectures. And we have thousands of containers with variable lifespan. We have some containers that are running like for seconds. We have other containers running for hours, days, years even. And of course, all teams started collecting data. So now you have data when you deployed, what do you deploy, how the application is performing, everything when it comes to insights around it. But we also have some challenges, and those are really connected with the current state. The first and most important one is the increasing datasets that we are getting in our applications. Those datasets, of course, can cause struggles because we used to have, for example, transactions that were in an amount of millions, and now there are billions or even trillions or whatever, depends on the scale of the company. And at the same time, we have components that have too many dependencies because every microservice, for example, might be depending to 10 different services, or there is there's high complexity in more modern systems. Traditional scaling is not always sufficient though, in terms that when you have dependencies between services, it doesn't necessarily mean that by scaling service A, I'm just solving the problem. The same goes like even if you have like a dependency graph for those, it might be the case that you have a bottleneck somewhere else. And scaling is still slow when you have traffic spikes, in terms that you're always kind of reacting, let's say, to the traffic that's coming in. Finally, and this is the most important one, there is no one-to-all metric, which means that essentially it used to be that we could scale based on, let's do CPU because this cluster is doing this, let's do memory because this cluster is doing this. But now we have so many different types of services that it's not very easy, let's say, to use just one metric for it. But if we want to scale containers from nowadays, right, we have a few tools already. And the first, most popular one, is the horizontal scaling, right? Most orchestrators coming out of the box with it. Mesos, Kubernetes, and Nomad have this one already. You don't even need to try, you just like configure your application, you use the base metric, there you go. They also have some functionality, those orchestrators, to scale working nodes. A very good example is with Kubernetes. So you just need to care about containers, you just scale them. If there is not enough capacity, you can just provision new nodes. You don't even need to worry about it. Kubernetes is going to do it for you. Vertical scaling also came into play recently with a better version that Kubernetes talked about. And essentially what they're doing is that they're monitoring dynamically all the containers. And if you have any extra requirements, there can be two modes. One is to actually recommend and say, hey, listen, this application is not performing as expected, there is a spike over there. You can still overcommit, so up to a point you can kind of let it dynamically reallocate resources. But of course, the important part here is that think of containers like reporting jobs, right? That you know that if you have long-running jobs, most of the times it's the case that you need this extra capacity for a few hours or minutes when you're actually running the report, and then you don't really need the container. But if you have a service that it actually needs to be there, and you cannot just kill it with a scheduled job, for example, it means that you can really use that one. And there's another use case, we're going to talk about it later. So, but how do we actually scale? All those orchestrators come with some tools that, for example, they always monitor CPU, memory, response time. So they're still important metrics. However, they need to be context specific. Again, an example when we talked about reporting. Now we have also custom and external metrics. Both Kubernetes and Mesos supports those, but the problem is that if you talk about Mesos, for example, you need to kind of create your own adapter to be able to extend it. Kubernetes comes out of the play, you have Prometheus, you hook it up, it works. Another important topic is that if you define a key metric that you should trust per service, it doesn't necessarily need to be like infrastructure related. For example, it might be the case that you have an application using a specific funnel and that you want to essentially have credit checks, for example. If I have a credit checker that can do up to 10, 20, 30 applications per minute, even if I have a great application that can do thousands of applications, it won't work anyway. That's why it's important to focus in one key metric, and of course use the other metrics as well with it. And finally, setting disruption budgets. By default, Kubernetes uses disruption budgets for identifying containers that in case of emergency, it can just pause the workloads temporarily till it gets again important resources. This is something you can combine essentially with priorities, and you can get a pretty good deal in terms that when you have a spike, you can actually pause those workloads, use your resources for absorbing the spike, and then get it back. But there are some considerations as well, because although we talk about Mesos, Kubernetes, and all those great tools, they have their issues, and they will have those issues because environments can vary between cloud providers, between application stacks, and everything. So scaling can vary between those providers. Persistent storage is a big problem. There are some solutions out there that essentially you can work around some issues, but if you have like node-specific persistent storage, it means that you're going to end up having this problem because essentially, if you lose a node, you're losing, of course, data. If you don't lose it, it means that this node will stay there forever. Rebalancing tends to be tricky as well because you have multiple availability zones, multiple instance types, and it can be very, very tricky. But pausing the workloads, as we mentioned, it's a very good strategy. If you don't do it, start doing it now, especially for some jobs that are not very important or not very time sensitive. And the vertical load scaler can help you optimize your containers because most development teams are actually over-provisioning the containers in order to not have problems in the future. But it's not a very good strategy for the platform teams because it means that you're actually spending money without actual utilization. Now, if we go to a more generic concept of distributed systems, right? Still, when we scale those systems, they need to be, well, you need to have data, so data-driven decisions. But the most important part, and this is something we're missing in most platforms, is that we need deep understanding of the platform. For example, being a DevOps engineer or a platform engineer or an SRE engineer, it doesn't mean that you don't have to spend time with the code. You need to understand at least what it's doing, and you need to understand how exactly all those components that you have in your platform interact. Of course, observability in the service graphs, now that we're talking about service meshes and everything, can help you on this, because back in the days it was really hard to try to understand what are the bottlenecks and everything. So all the modern technologies like distributed tracing and all those things are actually giving you so much information that we didn't have back in the days. But there's still some considerations, because for example, when you want to scale streaming platforms, you need a very specific way to do it. It's not that you can just add, for example, extra nodes, or you can just scale it vertically or anything, because all those applications that are actually using those streaming platforms need to be aware of how and what you're trying to do over there. Some data engines still use single processes. I mean, it's pretty common, even like in MySQL and Postgres, depending on the version you're using, that you have single processes. So even if you scale tremendously your application, it's very efficient. If your database is slow, then you don't actually solve your problem. Third-party services need to scale as well. The Amazon S3 example is more like to explain how you can easily hit your API limits. So, for example, especially for services like Athena and all those internal services that can go through terabytes or petabytes of data, it's really easy to start hitting limits. So even if your application is amazing and you can do amazing things, still the third party limits you. The same goes, for example, if you have like an external payment processor, right? If it can process up to 20 or 30 payments per minute and you want to do like 1,000 or 2,000 or 10,000, still it won't work. And last but not least, bad code will always win. So if your engineers are writing bad code, yeah, sooner or later you're going to have to fix that. However, let's talk about the future of scaling. This is the most important thing, and this is the most exciting part for me. We're collecting data, right? So let's do something with it. Because they're just sitting over there like in Datadog, in Prometheus, in CloudWatch, whatever the tool that you're using is, right? There's data in there that we don't necessarily use after a few weeks or months. All our techniques, everything we talked about so far, it's how we can scale in a reactive mode. So first something happens, like I'm running out of memory, I'm running out of CPU, and then, oh, okay, I need to scale now, so I need extra capacity. But what if we move to a more proactive approach, something that it can actually tell us, hey, something's going on over there, so probably you're going to need something extra. There are already some tools out there that kind of offer it, like Datadog, for example, with forecasting and predictive modeling, but it's not exactly what you need, because those systems are not really aware of how your business runs, of what you try to do in your platform, what are you trying to do with development teams. So essentially, we're talking about predictive scaling, which is forecasting. And there's so much community work already available, but for some reason, there are not that many people that actually use those tools. So think of it like you have a great big platform, like billions of requests per minute or per second. And you're trying to see how you can be more accurate in your capacity, because, of course, just having nodes over there burning money, it's not ideal. And sooner or later, business will come to you and say, hey, we're spending too much in AWS or Google Cloud or whatever your provider is. So a very good example is the profit modeling strategy, or the good old Fourier. So for those of you that are more like in data science area, probably you're already aware with those algorithms. But how does it sit with what we're talking about? Well, essentially, we keep track of trends. We try to understand what's going on. We try to understand when the traffic is coming in. And again, traffic is not necessarily HTTP requests or gRPC calls or whatever your system is about. It means that for companies like, for example, Funding Circle, our funnel is expanding internally. So maybe you have like 10 loan applications, but that will generate a huge spike internally. There are so many services, there are so many things running under the hood, so the end user will never see what's going on over there. So, talking of profit modeling, who has heard of profit modeling before? Good, very good. So, for you that are not that familiar, this started as a project from Facebook. It was an attempt from their side to actually start anticipating traffic and creating patterns that then the infrastructure teams could use, but they could share also the data with other departments to understand how people are actually using their platform. It's a modular regression model. Happy to talk about it after the call, after the talk with you to explain what that is. And essentially what they do is that those are some plug-and-play models that analysts can provide feedback on the fly. This is more to avoid false positives and make sure that essentially if something's happening over there, everybody is aware of it. So the analysts, of course, in the loop is more like our production engineering teams that are actually checking like from the site reliability perspective, or it can be even development teams that are actually monitoring how a tool that we released a few days ago is working. And here you can see essentially what is the pattern based on the year and based on the day of how Facebook was receiving traffic back then. There is a very interesting paper, I can share it with you, and also like a very good collection in GitHub with tools around this. What you can do with those is that you can essentially hook your metrics from Prometheus into SageMaker. Use this, it's available as a notebook from Jupyter, so you can just run it over there and you can immediately start creating results. Of course, the way you're going to use it later on, it's totally up to you, but it's something that you can leverage for. No, I'm not done. There's some beeping here, that's why. So, closing remarks. First of all, you need to understand your platform. It's very, very important to understand your platform. Keep collecting data. Is it going to explode or? Okay. Ensure that your external dependencies can scale as well. Make sure that you keep everything in track and make sure that, for example, your data engines can support the scale of an application coming in with thousands of replicas. Don't rush your teams using the latest tools for production. That was a very, very big problem when Kubernetes went out, because for the first 2 years, who used actually Kubernetes before 2017? Okay, you three know that. No, but seriously, it was in the beginning. I mean, it was a great project, but it has so many bugs that, well, not only bugs, but security exploits as well and everything, right? And finally, predictive scaling is the next big thing from platform side. Machine learning will help us with that. So if you haven't tried it, have a look with SageMaker and what we talked about. And yeah, you're going to see huge difference. So before the questions, for you that are asking, this is the actual project. It's in GitHub. You can look for Forecast Prometheus, and here it has, yeah, so this is a project here. And here it has essentially all the different models that you can use to exactly do that. So now, do you have any questions?
Questions about us?
You've got the name from your project then.
Forecast Prometheus.
Can also.
There we go.
Question.
Any other questions for Panos? Over there. Oh, hang on. We won't get it on recording.
You mentioned that there were 280 people in the engineering function at Funding Circle, and then 40 in platform.
Correct.
And then you provide the services for the developers. I was wondering, that platform team, are they integrated into the development team and they work in sort of individual squads, or how does that all work?
That's a very good question. So for now, it's not an integrated team. What we're planning to do is, while we're adopting more and more SRE principles here in the company, we want to have people that are working closely with the teams. So even like in sprints or longer times, actually work directly with the teams. But what we've done now is that we implemented a self-service project that essentially all development teams have different AWS accounts and they can actually try everything out. They're familiar with the infrastructure as code already, so they can essentially contribute directly in our repositories around Terraform and other things that they might want to add. And once we get to that point to have individuals, let's say, working with teams, perhaps it doesn't even need for them, let's say, to actually work in the team. They can work closely and they can be allocated like for a couple of weeks, like that's the plan.
Okay, we're just bringing Peter in. Can you please wait to start digging into the bits until we finish the session, but we'll have a break after this. Anybody else got another question for Panos? Did somebody say there was one down the front? Please, from one minute.
There was a mention about the scaling based on metrics and business metrics as opposed to infrastructure metrics. How easy was it to get those business metrics in place or identify those?
Right. So we are in the process actually that we have defined the first version and we actually go deeper in the funnel. Right now internally the company has different focus areas, let's say, or domains that we call them. So essentially it depends, let's say, in exactly which part of the business, let's say, that you're touching. It might be, for example, originations. It might be the case that we're talking about the marketplace, etc. So what we've done so far is that we collected stakeholders from all those different teams, and Anand is actually running this project as we speak, and we identified some key metrics that can in the future be used as service level objectives. So essentially, the indicators, of course, for every domain are going to be slightly different, but at the end of the day, it's all about your business, right? So, for example, a very important metric for us is if for some reason the funnel is blocked, like the amount of money we can loan actually to people, right? This is the most important metric that we might have up there, right? So you start from that, and then you can be smart also with your incident reporting, because if you start creating services around those, well, it's kind of specific to the company and the business, right? But if you start creating services around it, it means that every time you have a specific part of your business affected, you can actually see what's going on and you can actually see all the metrics that are affected by this. But the second part is that we already have custom metrics coming directly from the applications. So for example, when there is a failure or everything, those metrics are pushed to Prometheus. So it's easy to query and see what's going on over there.
Good stuff. Anybody got one last question? Time for just one more? No?
There's one back there.
I'm not running. It's going to be on camera.
I've not used Prometheus before. I was wondering if they have like a plugin ecosystem and this is something you can tie into that to be able to use those techniques, or if it's something that you would run separately on it to get that insight.
So essentially, Prometheus by default, you can query it, but think of it more like it's a time series database, right? So you can query it, and from the notebook directly, you can have like an interface to query based on the specific metrics that you want, right? What you're going to need, though, is a place you actually run your notebook. So, for example, that can be SageMaker if you want something simple, or you can have like a Spark cluster or like any Mark cluster or whatever. It depends on your setup, and also it depends on the provider you're using. But long story short, from a machine learning perspective, you don't need to spend too much time on creating the model. You just need to create the data sets for the model, and actually based on the context that you're providing through Prometheus, to make sure that you're using the right metrics for your business, right? Yeah.
Excellent. Okay, so let me go to Peter in a second. I just realised something. Panos,
yes.
You're Greek, right?
Very.
Okay. So hopefully you can settle a debate for me here. If you're Greek, there's a certain Greek word that begins with K that's been mentioned quite a lot tonight. How do you say that? How do you pronounce that?
So originally it's come from Kubernetes, which is the Greek word, well, it's Kubernetes.
Kubernetes.
Kubernetes is kind of commander.
I'm not saying that.
Yeah, well, you can try it. It's not that hard.
Kubernetes.
Kubernetes, yeah.
There you go, everyone.
There
Next
you
time
go.
you want to have a conversation about Kubernetes, that's the result.
Thank you very much. Enjoy the pizza.